Hello everyone, my name is Jamaica M. Reyes and
My name is Jim Brian R. Prila from BSIT to M1.
today we will explain our finals in Cc4. Our using in this code is C program. So let's start. First, we need to insert all the code of main menu. So here are the list of main menu. Number 1, sorting, bubble sort and selection sort. Number 2, binary tree traversal, pre-order, post-order, and in order. Number 3, queuing. Number 4, stacks. Number 5, about. And number 6 is exit. These are the first output. So let's start with bubble sort.
Bubble short. Sinking short is another name for bubble short. This algorithm compares each pair of adjacent items and swap them if they are out of order. And it repeats proceed into no swap are needed. In the following program, we use the C language to implement bubble sort. The user would be asked to enter the number of elements as well as their value, and the program would then use the bubble sorting algorithm logic to sort them in.
Here are the output of bubble sort. Selection sort.
For ascending order. There are the three process in how to create selection sort. Number 1. Find the array the smallest element and swap it with the element of the first place. Number 2. Find the smallest element in the remaining array and swap it the element in the second position. Now we have two elements in right places. Number 3. To sort the list must be repeated in one times or time.
Here are the output of selection sort. Binary tree traversal, pre-order, post-order, and in order. In binary tree, traversing a tree entails visiting all of its nodes. You may want to add all the values in the tree or find the largest one. For example, you will need to go to each node of the tree for each of these operations. Consider how we can interpret the tree's components. Although this method is simple, it ignores the tree hierarchy and only consider the depth of the nodes. Instead, we use tree traversals methods that account for the tree's basic structure. We should think of the struct node pointed by the left and right as a subtree rather than a subnode because it may have other left and right children. Remember that our task is to visit each node, so we must visit all nodes in the subtree as well as the root node and all nodes in the correct subtree. There are the three forms of traversal depending on the order in which we do this. Here are the output of binary traversal, pre-order, post-order, and in-order traversal. Queue. In programming, a queue is a useful data structure. It's similar to the ticket line outside a movie theater, where the first person to join the line gets the first ticket. Queue follows the first in, first out rule. The item that goes in first is the item that comes out first. Enqueue is the programming term for adding items to a queue, and dequeue is the term for removing items from a queue. We can implement the queue in C program. Here are the queue operations. First, two pointers, front and rear. Second, front track the first element of the queue. Third, rear track the last element of the queue. Initially, set value of front and rear to -1. In enqueue operation, first, just check if the queue is full. Second, for the first element, set the value of front to 0. Then, increase the rear index by 1. Fourth, add the new element in the position pointed to by the rare. And here's the output of queue operation. Stacks. In stack, a stack is an abstract data type that can be found in almost any programming language. It's called stack because it works like a stack in real life. It has a LIFO data structure because of this functionality. Last in, first out, or LIFO, is an acronym for last in, first out. The element that was positioned, inserted, or added. Last is accessed first in the case. The insertion operation is referred to as a push operation, while the removal operation is referred to as a pop operation in stack terminology. Initializing the stack, using it, and then the initializing it are examples of stack operation. A stack is used for the following two main operations in addition to these fundamentals: pushing or storing an element on the stack; pop, removing or accessing an element from the stack. We must also check the stack's status in order to use it effectively. The following functionality has been applied to stacks for the same purpose. Pick, get the top data element of the stack without removing it. Is full, check if stack is full. Is empty, check if stack is empty. Here are the output of stack. About. In about, we insert our name. Last is the exit.